Hello and welcome back to Zig's Math Lessons. I am your host, Ziggelviet B. Stunk. Thanks for dropping by. Today we're going to look at some uses for these trig functions, as in modeling some word problems. When you read a word problem, you will look for things you need. One thing you will need is a maximum and a minimum. It will be hidden somewhere in the paragraph. An indication of the period or the length of the cycle. And finally, within the paragraph, you will find an indication about the desired starting point. Should the curve start at the bottom? Should it start at the top? Etc. Let's do an example. The water at a point on a shoreline rises and falls with the tide every 12 hours. The highest point reached is 9 meters above some reference, and the lowest point is just 3 meters above that same reference. Determine an equation for the height of the water over time, assuming that low tide occurs at midnight. Okay. First of all, the amplitude is max minus min over 2. And the max is 9 and the min is 3, so 9 minus 3 over 2. That's 6 over 2, which is 3. And here we go again, going after amplitude, period, and shift. Period? Well, it said it follows a 12-hour cycle, so a period is 12. But since we're looking for an equation, we know that period doesn't show up in the equation, B does. And B is 360 divided by P, 360 divided by 12. So we have B equals 30. And finally, we want the shift. That means the axis of the curve, which is max plus min over 2. 9 plus 3 over 2, 6. Now that we have all of this data collected, we are now ready to make an equation for the situation. But we might sketch it first. It says low tide occurs at midnight, so here we have low tide occurring at the beginning. And as the clock ticks, the tide comes in and out. Comes in, goes back out. At noon, it's low tide again. So this is a sketch of the situation. We have our max, we have our min, we have our axis of the curve, which we figured out to be 6, and we have a period, which is 12, the length of the cycle. Now we're ready to make an equation for this. We would compare this visually to a cosine curve that's been reflected. See, normally cosine curves start at the top and go down. Well, this one starts at the bottom and goes up. So a negative cosine curve will work for us. And with that in mind, we construct an equation. H of t equals negative 3 cos 30t plus 6. How did we come up with this? Well, it's a cosine curve with a negative sign in front of it, with an amplitude of 3, and we figured that out up here. The amplitude was 3. The b value is 30. We figured that up here. B value equals 30. And the axis of the curve is 6, and we figured that out right here. So we use all this preliminary work and the fact that low tide occurs at midnight and this sketch to make this equation. And this equation is called a model. It's a mathematical model of the height of the tides. Let's go again on another one. Example. A Ferris wheel rotates once every 30 seconds. The diameter of the wheel is 16 meters, and the lowest point is 1 meter, so that people can get on. So it comes down, and it reaches not quite the ground, 1 meter above the ground. Determine an equation for the height of the wheel, starting again at the lowest point. So away we go. That's a wheel, and that's the ground. That's 1 meter above the ground, and since this Ferris wheel has a diameter of 16, that must be 17 up there. And in the middle, between 17 and 1, we have the number 9. 17 plus 1 divided by 2 is 9. So the number in the middle is 9. And that's the axis of the curve. The period of this curve is 30 seconds. And so I've drawn it out here to 30. And we can now draw the curve in. Again, it looks a lot like an inverted cosine curve. Amplitude is 8 because remember we go max minus min over 2. So 17 minus 1 over 2. Period is 30, so therefore the B value must be 360 over 30, and that's 12. Amplitude, period, and then now the shift. Let's take a look. At this point, we've achieved amplitude and period, and all we have to do is take a look at the drawing and say what the shift is. It's been shifted up 9. The axis of the curve is elevated by 9. Or we might say the axis of the curve is 9 because 17 plus 1 divided by 2 is 9. So now that we have amplitude, period, and shift, we can go to making our equation. And once again, we might consider this to be an inverted cos curve. So we can construct an equation thinking about an inverted cos curve. There's one. Negative because it's inverted. Cosine because it's a cos curve. 8 because the amplitude is 8, we figured out. 12t because the b value is 12, we figured out. And then plus 9 because the axis of the curve is 9. Let's take a look here. Inverted by the minus sign. Amplitude is 8. B value is 12. The axis of the curve shows up right here. It's 9. There is another answer to this. In fact, there's many. But one might consider this a sine curve. And if one did consider it a sine curve, one has to look at this point right here. From that point, the curve leaves the axis of the curve and goes up. And that's what a sine does when it's not been shifted. But this one has been shifted to the right a quarter of a period. If we were to consider it a sine curve, that is. Since the period is 30, a quarter of 30 is 7.5, we could consider this a sine curve that's been shifted to the right. So we could turn this cos into sine and take this and put brackets around this t and shift it to the right a quarter period. Thusly, a quarter of 30 is 7.5. I'm Ziegeldiet Biestunk, and thanks for watching. If you liked it, leave a like, and if you like the content, please subscribe. Check back daily for updates and new videos, and I'll see you soon.